Alright, you ready to learn about one-step dimensional analysis? Because it's going to be something that we use from now until the end of chemistry. So, when we are talking about this, we have to know our metric units. So, right here where it says, write a conversion factor that can be used to convert from grams to kilograms, meters to centimeters, or cubic centimeters to cubic meters. That doesn't mean that you have to have all of this memorized yet. You have this handy-dandy conversion thing that you can use. So, this you got in your notes. It's in Schoology. Please, please, please use it. Please, please, please go back to it over and over and over again. So, when I am looking at a question such as this one where it says write a conversion factor that could be used to convert from grams to kilograms, well, I can use grams, meters, liters, and seconds interchangeably. So where it says grams to kilograms, that could be meters to kilometers. So I go over here, I look, I see 1 kilometer is equal to 1 times 10 to the third meters, or 1,000 meters. So the way that I would write the conversion factor right here for grams to kilograms is I would write it as I have 1,000 grams for every 1 kilogram. How would I rewrite those as conversions? I would do 1,000 grams for every 1 kilogram, or 1 kilogram for every 1,000 grams. When I see that I've got meters to centimeters, I know that meters is bigger than centimeters. Because if I go back and look, so you go look at your conversion chart, you can see that this time meters, or the base unit, are bigger than what we're converting to. So this time my base unit gets the 1, and there's 100 centimeters in every 1 meter. So if I were going to write that as a conversion, I would write that as 1 meter for every 100 centimeters, or 100 centimeters for every 1 meter. And then for my last one right here, if I've got cubic centimeters to cubic meters, I'm going to go back and I'm going to think about the fact that, they're going to have to be cubed, and I would go from there. But we're not actually going to be doing much with volume. So for today, we'll talk about volume later on. For today, we are going to concentrate on using our metric conversion factors. So, make sure you have that handy-dandy little conversion factor chart ready, and we'll get going. So, when we're doing one-step conversions, I always follow these six steps. I write down what I'm given, I draw a chart, or I draw a T, and you'll see what I mean in just a second. Then I slant my units down, I write the new units, and then I fill in with conversions from my conversion factor chart. Then I cancel units and solve. So, we'll come back and we'll talk about these. So right here it says convert the following. 89 seconds to milliseconds. That's what the little m means. S means seconds. So what I'm going to start by doing is step 1, write what I have. 89 seconds. Then I'm going to draw the T. And it looks like this. Okay. Step 2. Step 3, slant my units down. So seconds goes down on the bottom. And then I'm going to write my new units on the top to milliseconds. Seconds is one of my base units. Since it's one of my base units, I know this is a one-step problem. So what I now do is I go look on the conversion chart. So if you go look at the conversion chart that you have, you can see that seconds, anything seconds or meters or grams or liters, that base unit is bigger than the prefix milli. So what that means is I look at that relationship, and for every 1 meter, there are 1,000 millimeters. So that relationship is true no matter what, and that I am going to put a 1 with seconds and 1,000 with milliseconds. Okay? 1 with seconds, 1,000 with milliseconds. Why did I not put a 1 with milli and 1,000 with seconds? Because that's not what the relationship is. You have to pay attention to what the actual relationship is. So now what I can do is I can cancel seconds, and I can multiply and divide. So 89 times 1,000 divided by 1 is going to give me 89,000 milliseconds. And that is my answer. Alright, next example. Alright, right here I have 460 decimeters to meters. So, first off, meters is a base unit. So that means I know it's going to be a one-step problem because I'm going from a unit with a prefix to a unit with a base unit. So I'm going to start by writing the number. Step 1, 460 decimeters. I'm going to start with decimeters, draw the chart, slant the unit decimeters down, and then put meters up here. So, remember last time seconds went on the bottom, this time meters goes on the top. It's not always going to be the same every single time. You really have to pay attention to what is going on in the problem. So it is always more important to pay attention to your units. Where are your units going? Why did I put decimeters on the bottom? Because that way it will eventually cancel. So when I have decimeters and I have meters, I have to go look at my one-step conversion factor notes that you have. I go look at the chart and I find decimeters in that it is smaller than the base. So when I look at that, it says on the chart that 1 meter is equal to 10 to the first, because remember there was 1 desk in the middle of the room, and that's also equal to 10. So 1 meter is equal to 10 decimeters. So now what I have to do is I have to look at, okay, 1 meter is equal to 10 decimeters. I put the 1 with meters, I put the 10 with decimeters. So now I can cancel out my units, and I do 460 times 1 divided by 10, and my answer is going to be 46 meters. Alright, one more for the road. 3 kiloliters to liters. So, I'm going to start like I have all the others. I know that this is one step because it's kiloliters to liters. I'm going to a base unit. So I start by writing my number, 3 kiloliters. I set up the chart. Kiloliters goes on the bottom. I slant it down. And then liters goes on the top because that's what I'm looking for. So I go look at my conversion units, and this one's a little bit different because I find the prefix kilo in that it's bigger than the base. So I'm going to go ahead and write what I have on my chart, which is that 1 kilometer is equal to 10 to the third meters, and that's 1,000 meters. So what that tells me is that kilo is 1,000 times bigger than my base unit. And remember, we can use meters and liters interchangeably. So what's going to happen here is, this is opposite of the others, is because kilo is bigger, kilo gets the 1, and there's going to be 1,000 liters in 1 kiloliter. So I have to pay attention to my units and then choose the numbers with the units. I'd rather you only write units and not write numbers than just throw numbers around. So now I can cancel out kiloliters, and I can multiply 3 times 1,000 divided by 1 and get 3,000 liters. And that is how we do one-step conversions.